Great.
Before we move forward, I just would like to remind everybody or tell everybody that we are recording this session. So I just want you to know that I'm recording the interactive parts of this, not the chat rooms, but the main part of it. So just to notify you. So shall we, anybody have anything else, or shall we move on to the activity? Ready to go? Okay, let's go.
All right. Well, this is this is a force and motion activity, I just wanted to start off by saying that being in informal education, I've had an opportunity to do lots of hands-on things with students, and so I've got a lot of experience. I love doing that. I love bringing science to them. You know, when I was at the center, for example, or on outreach programs. But this is my first ever distance learning teaching moment that I've been driving. So I am definitely open to your feedback at the end and would love to hear. But it's exciting and fun for me personally at the same time. And this lesson that you're going to witness was something that I just kind of came up with. So I'm just going to frame it that way. There's lots out there, as we know, on force and motion, and I did do some best practice and, you know, bringing in things that I did at the center when I was there. But you know, it's just, I just want to encourage you all to feel empowered if you don't. I know time is always a piece of this challenge, but just think of your homes as laboratories. Think of your homes as classrooms. How do you set them up? I've had fun watching the distance learning classroom that my wife has set up, and both here at the house, but also in her school. She's just using a fraction of her classroom as her classroom, right? And so she's been able to control the environment in very much the way she wants. So think about the physical layout in space. I didn't do a lot with mine today, but have a dry erase board. And anyway, have fun with your surroundings and take advantage. Introduction to force and motion. So force, these are just Webster classic definitions: strength or energy exerted or brought to bear, cause of motion or change, active power. And then for a definition on motion, an act, process, or instance of changing place, movement. And if you want to think about these prompts or questions, guiding questions, why are these concepts important to our students? Why do we want to teach them about these ideas? And rather than popcorn in too many ideas verbally, let's just feel free to drop those in chat right now, just to kind of capture some of your creative ideas about why force and motion? Why do we see it embedded in our standards? Why do we teach about it? And I'm going to move forward. And as you're thinking about why we teach them, here's a few images and GIFs that reflect some of the principles of forces and motion. So you might use the prompts at the bottom of the screen, I notice, or I wonder, as an opportunity to engage in these images and animations. What do you notice or wonder about anything you're seeing on the screen? And again, if you have your notebook handy, if you want to jot these down in your notebook, that'd be fantastic. Feel free to again, include them in the chat. Any ideas about what you notice or wonder about these images and how they might relate to forces in motion. We'll just spend a minute or two here. Oops, hopefully did I make you all go away? Hope you're seeing my screen still. Okay, spend another minute entering ideas in chat, jotting them down in your journal, or just even on a blank piece of paper. If you don't have a journal, that's absolutely fine.
There's some great stuff in the chat.
You want to call them out, Betsy? Go ahead, or have people share it, either way.
I just, that force and motion underlie a lot of phenomena that students see every day. and to build on for later science. Cause and effect is a really important part of forces in motion. It's an intro to the topic of energy. So those are all great reasons why. It's also stuff that we can see. Some of the observations are, I noticed that when one metallic ball hits the side, the ball on the other side moves. People are wondering how long the movement will last.
That's a good one.
Oh, you can look at this. I think the, I forget what that's called. The something cradle is really interesting.
Cradle, I think, yeah. Or is that what it is? Yeah.
Anyway.
All right.
Newton's cradle, thank you.
Yeah.
Making predictions.
Great. Well, I'll move us on from here, but thank you. We're going to be capturing all of these ideas from the chat as well. And so we appreciate you dropping your thoughts in there. Okay, we're going to start the core of our activity. And we're just sort of time check for everyone. We're technically about 15 minutes, a little bit behind where we were. So we may truncate a piece of the activity, but as it was laid out, and you'll get the full slide deck, and we can explain the thinking around the sequencing here. This is what we are hoping to accomplish. So we're going to explore forces in motion through a completion of a series of 3 challenges. And we're going to refer to the overall challenge as the drop challenge. And for those of you that can see my whiteboard here, it's simply that we're going to drop an object onto a pile of other objects, and we are going to see what happens. And we're going to go through sort of a scientific process, if you will, or a procedure to kind of move us through that exploration together. So think about that simple idea of dropping one thing on a set of other things, and what that tells us about force and motion. So the first challenge we're referring to is drop challenge. The intention was to run the drop challenge twice. We may decide to actually skip that, but we can at least talk through the rationale and the ideas, and I would love to hear your thoughts about repeating an experiment or an activity and why that might be important. And then the third one we do want to for sure get to is this, what we're calling change a variable. And we're going to do that in small groups. So we're going to send you back into the breakout rooms so that you can do a little bit more in-depth exploration of this third challenge, because it's going to allow you to tweak or change the environment. You're going to have some choice. You're essentially going to get to change the model or the activity and then run the experiment yourself. And then things to think about as we're doing these challenges overall. What's the basic relationship between a force and motion? How are they connected? And even though we're not explicitly talking a lot about energy today, it's embedded in those concepts, right? So how does it fit in? Where does energy fit into this force and motion idea? All right. So the supplies you'll need, and just a quick show of hands, who was able to gather supplies today prior to the workshop? And again, no pressure if you weren't, no pressure, we get it. Distance learning and grabbing stuff can be its own as anxiety-provoking experience, but you don't need much. And so that's what I really wanted to emphasize here. So there's a picture on the upper right of what you'll need: pen or a pencil, 3 different markers or crayons, colors, something to write on, to take notes on, something to drop, a set of other things to drop on, and a playing field or a platform to drop that stuff on. Okay, that's really all you need. And you can think creatively out of the box on all of these materials, especially what you drop on. I mean, if you didn't even have a paper, you could drop on the ground and mark with chalk, right? So just encourage you to think creatively about your supplies. And we know that can be an equity issue for our students, the time pressure of gathering these things in a distance learning environment. Totally understand. And if that's a source of friction, would love to hear more about that from you. Okay.
And I think it's also a good idea to point out here that we really encourage the use of notebooks. It's a way of bringing literacy into science. So this is an opportunity to have the students use their notebook to record their observations and their thinking. And there's even would be opportunities for them to draw models in their books. And there are ways they can do it on paper, but there are also ways to share it electronically, either by photographing it, and they could put it in a Jamboard or on a Padlet. And I'm sure you know way more ways than I do about having students share their work, but you know, a regular formatted way for the students to record their observations, because that's really important when you do science. You don't remember stuff, you got to write it down. And so we really encourage the use of notebooks.
And to just emphasize Betsy's point, sketches and diagrams are part of that, right? It's not just about the writing piece, but it's about the visual piece and how we understand what's going on. And then those become models in and of themselves. Those images, right, are models of our activity and what we intend to do. So really good stuff with journaling. And it gives you a chance. It gives you the paper trail. It gives you an assessment tool, an additional assessment tool to see where your students are at. And I always like, I believe in personalizing journals too. So you can see a couple that I put down that I've done in the past. Just fun way to really make it their own experience and their own, have ownership of it. So activity setup. Again, for the activity itself, you're gonna need a marker. I'm gonna drop a key, or I'm not gonna do it, but I did drop a key on that set of Legos. So those are the things I chose. And then this is a little sorting box that I put together with a whole bunch of things that you could consider dropping on that would be readily accessible in the home. I will readily admit that that M&M pile is much lower than when I started the exploration. So anyway, use things that are around you. Recycled items, reused items, good stuff.
When I tried it, I used a small potato.
And then for your notebook setup, just if you could just jot down the object that you're going to be dropping, the objects that you'll be dropping upon, and then how high you intend to drop it. And here I'd like you to use descriptive words. We're not even going to worry about rulers or string or what have you, which are certainly scientific tools which you could bring in, but just I'm going to drop it from knee high. I'm going to drop it from my waist. I'm going to drop it from my head. Just those descriptive words, you know, about where you're going to be dropping from, just to kind of add that into our equation. So that's our setup for our notebook. Just a little bit of logging of what we're going to be using. And here's our procedure that we'd like you to use. And I'm just going to call it a three-part procedure: a predict, an experiment, observe, and record, and a reflect as our three-part kind of procedure. Prediction, of course, includes some of those ways of thinking, like what, before you even do the activity. So what, you know, you're going to take, I'm going to take this key and I'm going to drop it on those Legos. What do I think is going to happen? And maybe why? And just express that in your notebook. And then do it. Do the challenge, do the activity. And we're going to add one other piece of documentation to this, this doing the activity, and that's to mark. You could do it a couple ways, a couple steps in this. If you want to circle the pile of objects, I'm going to ask that you group your objects all together so they're touching each other when you do the activity. So they're in some kind of cluster or pile. And you can circle those with your marker if you like, just to sort of indicate where you've started. You don't have to circle each one, but just the whole group. And then after the drop, you're gonna, any movement of those objects, you're gonna circle their new locations. So this is a way we're gonna map, just create a map. And again, it's a visual results chart. So it's its own kind of data chart in and of itself. Again, you can imagine where you could go with this, measuring it, etc. And then the last piece, we want you to reflect on what happened. Just simply, what did you observe happen? Okay? Any quick questions on, yeah.
There's also an opportunity, if you have a focus question to start with, you can go back to the focus question and interpret what you observed in terms of a focus question. So reflection can also do that.
And just drilling down quickly into each of those three parts of our procedure: predict, observe, reflect. For the prediction, again, what do you think will happen? And you can use these prompts. I'm sure you're familiar with these. I think that this might happen. I imagine that that might happen. It's just kind of your hypothesis, your prediction, your idea. What do you think is going to happen? And don't, you know, again, you have the slide deck, so don't feel like you need to jot all these things down, right? Unless it's helpful. And you will have 5 minutes to do the activity on your own. So I'm gonna have a timer on the screen, and then you're free to jump up and just start the exploration on your own. And then we'll come back and we'll look at those other two pieces of our procedure, which we're doing the activity and the observation that goes with that. And then the reflection, you know, what actually happened and why. Okay, so we're gonna start our timer. Hopefully this works. Ready, set. Scientists, Go.
So set up your pile, drop it, mark where they go, and then think about what happened.
And have fun.
And have fun, most importantly.
And anybody that's brave enough, you can, and you have the right device, feel free to spin your device over and you can have the rest of the team engage in your exploration. I think that's fantastic. I love what I'm seeing.
Yeah, how fun to see.
Yeah, this is great. My wife was giving me a hard time because every time I need to look close to the screen, my head gets really big.
Yeah.
I'm trying to see everybody's experiments.
So for a symbol drop, we're just supposed to drop the individual objects?
Yeah, just a single object on a small pile of other ones. I suggested 5, but you know, you can get creative with as many as. I also didn't maybe clarify. It would be great if all the objects you're dropping on are the same, same size, same shape, same mass, essentially the same object.
So what we're dropping on are all the same, but what we're dropping can be different?
Yeah, yeah. But it's only one object at a time. And for the first exploration, we were just going to drop one. But if you want to, just for sake of time, for those of you that are still got one ear on the audio here, feel free to do this twice and map it, because that was what we were going to do. We were going to sequence it, but we were going to overtly, explicitly look at each challenge. But I think for the sake of time, if you feel like you can drop one and do it, but what I'd ask you to do here is replicate that first experiment almost as best you can, identically to the second one would be the same as the first.
So
all the strings, all the variables are the same.
You didn't happen to have a model that you showed us before we did this, right?
I'll show you what I did. I do have a picture. Let me see.
I think I did it wrong.
Okay.
I dropped my items, but I dropped them on the page.
Here's the closest I have to a model is that image on the screen right now.
Yeah.
Me holding the key above the Legos on top of the paper, and then just dropping it from that height.
So what you're doing is you're looking at, there's a pile of objects and you drop something onto them, and then you're looking at what happens to those objects that are in the pile when they're struck by the object that's dropped on them.
Right. So that Legos, is that a small pile of Legos in the middle there?
Yeah,
Yeah.
it's a small pile of orange Legos at the bottom there.
Right.
And then that's my key.
And you could drop the same thing. You could drop a Lego on Legos too. I mean, it could be the same thing. It doesn't have to be a different thing.
You say they all have to be the same size? Because I have a whole bucket here of all kinds of goodies, but they're not the same size. I can make
No, I will leave that to you. I just suggested for simplicity the same to start, but absolutely encourage you to go off into those type of avenues and pathways where we think about, what if I use different size objects, different shapes, different weights, absolutely. Just to kind of simplify the first exploration.
I'm mixing it up. Thank you.
Yep.
I mean, you can kind of set it up any way you want. If you can control as many variables as possible, then you're getting a much cleaner conclusion about what's happening.
Mm-hmm.
But the process is the same, right?
Yeah.
Something hits something and then something happens.
Yeah.
So what can I just ask or say or comment? I'm finding what I dropped first just on the paper with nothing dropping. They bounced, one dropped and stayed, 4 others bounced away. Then I put a pile of stuff down and dropped them on there, and everything did the same thing. It bounced away except one stayed in the pile. So
interesting.
Interesting.
Yeah.
So can you go back and check the clock, Eric, please?
Yeah, you bet. Let's see. Oh, it stopped.
Yeah, I think we're ready to move forward.
All right, so let's come back together. If everyone can hear me, let's wrap up the first round of exploration and come on back.
I think we should just move through to a little discussion, but then go to the explain.
Okay, okay.
Talk about step 2 and then do the explain.
Okay. So again, here's an opportunity where you could spend some time on, sorry, I'm ahead of myself here. Oops. We want to differentiate between observation and interpretation or reflection. So we really want the students to kind of, with science, think about what they just saw happen without even trying to think about why, just what they physically saw happen. So important to just observe. So prompts like, I noticed that, I saw that, you know, without trying to explain. And then, so you could spend some time in your notebooks there, thinking about that.
You have a discussion with the kids. You can ask them, what did you notice? And
yeah. And we'll kind of move forward quickly, but with your students, spend time here, really spend time here. I did a lot of stuff at the center at Chabot, and we really delved into this idea of an raw observation versus an interpretation and how they really are different. Because even the words that we choose to use, for example, a balloon, the balloon is inflating versus the balloon is getting bigger, right? The balloon inflating implies I'm putting something in, I'm putting air into it. The balloon getting bigger is just a raw observation, right? So it's kind of even the words we're using, just being sort of attentive to that and encouraging our students to think about that. And that reflection piece and the other prompts, I think this happened because, maybe this happened because, a couple ideas there. Okay, and then what we were intending to have you do was repeat challenge 1 for challenge 2. And there were a few reasons for this. One was simply the idea that when we do science, it's so important to do many, many, many trials. We don't just do it once and then that's the truth, right? We're getting at the truth through so many observations, so many runs, so many experiments. And the more information we have, the better, I'd say the closer to the truth we can get, I guess. Maybe it's one way of thinking of it. And then this opportunity to just share the difference between doing an experiment once and doing it again. And do they come out the same? Or are they really different? And why? You know, that's its own kind of conversation. One of you that just mentioned, you dropped and you saw the Legos, you know, jump out. One stayed the same, so that was a similarity. But then, did the Legos fall in exactly the same place? Probably not. Why? You did the same experiment. So, you know, that type of thinking, like what are some of the levels of randomness and reasons that we might get different results, even inside of doing the same experiment? So that was our intention, but I think we really wanted to get you to challenge 3 because that's a chance for you to actually tweak the model. But Betsy, did you want to jump in?
No, let's move forward because we're going to run out of time.
Okay, we found this cute little video, so I'm going to play it. Betsy found this, and it's, I'll just play it and let it speak for itself.
Let me just say something first. So once you do an activity like that, where the kids are exploring something that's happening and they're observing and trying to interpret, and you're getting them to think and ask questions, now we want to give them some information that they can use to help interpret what they've been seeing. And so this video kind of gives a little more information. So now they're interested, and we can either give them a little reading, or you could give them a slideshow or a video that starts to explain and maybe introduce some vocabulary, science vocabulary that you want them to use when they're thinking about forces in motion and how they're related to each other.
And as we know, our 21st century students are drawn to video. It always cracks me up how I feel like I'm giving the greatest presentation in the world and I'm being dynamic and joking. And they're, you know, I got maybe 90% of the kids with me and 10% are doing their thing. Turn on the video and it's like a glue. It's like magnets. They're just all over it. So it's a different modality that they're used to, a different experience. Also, this is another model, right? It's a video model of these principles and these ideas.
I'm Dr. Jeff Vineker, and today we'll explore the science behind the energy of moving objects.
Let's
with Dr. Jeff. We're going to demonstrate a type of energy transfer called a collision. It's when one object runs into another object. Izzy, you're going to be our stationary object, which means you're just going to stand there. Mom, you're going to be our moving object, and you're going to run into Izzy on the other side of the gym.
Okay.
Team, any thoughts on what's going to happen?
I think that when Dr. Jeff's mom runs into Izzy, he'll fly back and she'll stay in place.
I think we'll both fly back. Let's find out. Ready? Set. Go! No, you were right. We just saw the transfer of energy by a moving object, and it happened when the two objects collided. The energy of one was transferred to the other. That's why one stopped moving and the other one started moving. Hey kids, you want to watch this whole episode and more? Tell your teacher to sign up at generationgenius.com.
So, any observations, any connections between that video and what you experienced when you did your drop activity?
Mine was the opposite of that, and I think it's because I was using a little, I don't know, little poofy fuzz ball, and I was dropping it onto paper clips.
Nice.
So you need more information then.
What was that?
Explain what you saw.
In my experiment?
Mm-hmm.
In my experiment, when I dropped the little fuzzy ball, it would just kind of bounce off of the paper clips. And one time it went one way about probably a good foot or so, and I used my foot to measure it. And then the second time it went the other way, and it went maybe 9 or 10 inches, and I used my hand to measure. So.
Yeah. We need more information about mass.
Sorry, Betsy.
I was just thinking we need more information about the effect of mass. Like if somebody else used if you use something heavier, what would happen? But that kind of sets us up for the next experiment.
Yeah.
That was my wonder. I wrote down, I wonder if the weight of or mass had to, yeah.
I had noticed that I dropped a crayon onto some place value blocks, and the crayon did nothing. And then I threw the crayon at them, and the crayon broke and nothing happened. But then I used a half-empty water bottle and dropped it, and the place value blocks all moved. And then I did it again, and one of them flew across the room. So I think the difference between in the video, the two things were kind of equal. But in this situation, the items on the floor had a floor holding them up. And so they weren't able to move as easily as the woman in the bubble was.
Mm-hmm.
You could kind of move horizontally, right, in free space versus, right, I see. Great.
So it required more mass in order to move them.
Yeah. I used jumbo-sized Legos, and I dropped a chapstick onto them first, and the chapstick just bounced off and barely moved the Legos at all. And then I dropped a fairly big metal coin onto them, edge first, and that moved the Legos really far away, and the coin stayed right in the middle of the circle.
Yeah.
Awesome. I'm really glad that you all actually started in on the variable activity, because, you know, given we sort of are pushing all this together, it's great that you just jumped right in. And, you know, if that's a better sequence for your students, if that's more engaging, go for it, right? I mean, you don't have to be so didactic about like, I'm just going to do this one thing and then I have to really reflect on it, you know. Make it fun for them, because distance learning is challenging, so it should be fun. But try and get at those things that you want to, the big ideas that you do want to sort of be in the conversation, have them be able to digest, still be mindful of those things, even if it changes.
And I think the point here is, and what you all are bringing up, is you start to do some drops. Now you have some information, and you can have a discussion about what variables might be important, like what things. So you bring out mass, there's height, there's all these different variables that are going on. And as kids could talk to each other and discuss what they've been seeing, now they can set up an experiment and actually test an idea about something. So that was the idea. The first two were really about setting up the procedure, thinking about the variables that affect how objects affect each other when they collide, and then be able to do an actual experiment where they intentionally change a variable. So
how
I
about,
think, go ahead.
Oh, I was just going to say a show of hands, because given the conversation we've been having about already tweaking a variable, show of hands, who would like another 2 or 3 minutes to explicitly tweak a variable, and who would maybe prefer the time to actually just gather together in breakout rooms and really think about how we might apply some of these things, given that we're at about 4:40 now, which was where we were thinking of transitioning you to the planning
So
time.
do you want us to raise our hand to more time or breakout group?
So raise your hand if you'd like more time for exploration with the dropping. See one hand there. And who would like to go to breakout rooms, just to be fair on the other side, just to, okay, it looks like, all right, well, the exploration is there for you, you know that. So feel free. But we want to value your time and want to value your time together. So I think that to me, I hear you loud and clear. Here's what we'd like
you
to
to
do.
the breakout slides.
Yeah, I think this is the beginning, Betsy.
No, keep going. We're skipping this planning time, right?
Yeah, I think these are some of the things we were thinking of, though. This is part of it. This is the beginning of the breakout room conversation, I think, right here. So basically, we just want you to think about these activities, this sequence, how you might embed them in your teaching. And we're going to give you about 8 minutes.
No, we're not going to do. We're not going to do the Jamboard. We're not going to do this. We're going right to the planning section.
Oh, I hear you.
Yeah.
Thank you. Got you.
Yeah.
Got you.
But go to the next slide.
Yeah. I don't know if I have that one in
no,
my.
No, go back. Sorry. There.
Okay.
No.
Do you have that Jamboard, Betsy? Or is that the same Jamboard?
No,
we're not doing.
We're not doing that one.
Okay.
Next slide.
So we're just doing breakout rooms.
Just the planning time. What would you do next? How might you use this with your class? How might you connect it to standards and vocabulary and concepts? I mean, you can talk about anything you want, but those are that's what we were thinking that you would find.
Betsy, I'm gonna I'm gonna put up the Jamboards I have, because that gives them a written place to document, if that's okay. But to Betsy's request and point, really focus on what you would do next, these prompts, these questions, how you would use it in your class, how does it connect to standards? So think about those things specifically, but I will provide a Jamboard link, a new one in chat, that will give you the option of, just recording some of your thoughts, even if it doesn't go with the Jamboard exactly. So I'm gonna let Betsy go ahead and, let me get that in chat, sorry. Well, maybe not. Sorry, I'm a novice at this. I'll tell you what, we're going to go with the original Betsy plan. Betsy, if you're good to just have everyone send them over to breakout rooms, I'll share this Jamboard afterwards, maybe as a closure. But just a conversation about what's next for you.
Okay, so I'm just going to send you to the same breakout rooms that you went to the first time. And we'll give you 8 minutes and see you back.
There you go.
So there's in our agenda, Teresa put a link. And the link, I put it in the chat, but a link doesn't work. I don't know what you call it, where it says WCCUSD 3 to 5 workshop, but that encodes a link, but it doesn't translate into chat. So
Yeah, and I have it as a hot link in the presentation, my Jamboard, but then I am happy.
Yeah, and that's always a great conversation. Welcome back, everybody. Sorry it was so short. I wish we could have given you a half an hour for that. But that's life.
But we've got some good news on that for session 2, right?
So let's see. It's almost time to get out of here. 3 minutes left. So
so we're going to run through real quick some just wrap up stuff. The first thing I wanted to show you was the Jamboard that we didn't use, but it will be available to you. And it's essentially just, again, another tool for your students to share and document and record, right? So imagine doing these challenges and using Jamboard so that they can talk about the variables that they tweaked, what their predictions were, what their observations were, and what their reflections were. So it's kind of breaking down kind of the 4 components that we explored today of doing an activity and exploration. The classics are predict, observe, reflect, but then we're adding in this idea of getting to mess around with the model itself and changing the setup. So just wanted you to see that. That's a tool that will be available to you.
Go ahead.
Yeah.
I was just gonna say, can we take a minute? Does anybody have any ideas or revelations that they'd like to share with the group from the breakouts? Things that you thought of that might be useful ways to apply this, or changes, tweaks you could make to it that might make it more appropriate for distance learning with your students?
Yeah, we talked about just the fact that, you know, somebody was explaining what they did, but their head's bobbing, and I did this and I did that, but we didn't see really what was happening. So it's really challenging when you are on a computer and you're in a Zoom room and you're trying to, you know, just explain what you're doing, but you can't really see what they're doing. And, you know, making sure that I thought it would be helpful, because I was a little confused as to what to do, but I thought it would be helpful to have shown the process, you know, how it worked for me before my students would do it, so they could see what they were expected to do. And then we also said that it would be challenging for the kids to get all the materials together, because that's always a challenge. But yeah, it's just a big fat challenge on the Zoom.
Do you feel that these materials are appropriate? I mean, is this simple enough materials? Is that a
Oh, I think so. I just think that, you know, you get, if you have 30 kids, imagine 30 kids, you know, you'll do that. You'll prepare them in advance, but the chances of them having all the materials as needed when you're ready,
right,
are kind of, you know, it's
one of the things I've discovered that works really well when you're doing an activity like this, especially where you're asking for variables and where you have kids who are doing things at different levels. And I have a huge equity issue in my classroom where I have some very strong boys who talk over the girls, is to pre-record your lesson. I use Screencastify, but there's other ways. Pre-record your lesson and then watch the lesson with the kids. So if there's any questions that you might have about it. And then those kids who take time and have to process and say, I don't understand or know what you're doing, they can watch that video over and over again. So you can link the questions to your video as well and say, then I want you to write in your writer's notebook. I want you to do 1, 2, and 3 and give it off to them. And I've had more success. I do a lot of engineering stuff, and I had more success with that when they had the video and I could say, just go watch your video.
Here's a question based on those ideas. One of the things we were doing at Chabot in the last couple of years that I was there was the idea of actually having the students experiencing the phenomena, doing it without saying anything. It was just like, just do it, raw observation, but then integrating all the tools you're talking about. Like, okay, now I'm going to do it as a demo, follow me, watch, or this video, you know, asynchronous video. Absolutely. So just throwing that out there as another way of engagement, that you just let them experience the raw thing without doing anything.
For this activity, yes. The one where we had to make droppy copters and make and make straw rockets, they needed to see how to do it.
Yeah. Something.
But yeah, I could see that. I could see this one being a little bit more self-explanatory with just some simple instructions.
Yeah.
Okay, it's we're late now. We need to let everybody go pretty quick here. We need to
Thank you, Ms. Weaver. That was helpful.
yeah, that was great. So any other gems?
Yeah. And we want to give you some exit tickets and just get you ready for the November workshop. So I know we want to do that in like a minute or two, right, Betsy? And then that'll probably be it.
Yep.
Okay.
Can you remind that date? No.
Is 17th?
17th.
Yeah. November
Okay.
17th. Same time.
There's a slide. Eric, do you want to go to that slide?
Let's see. So where is it? There?
Yeah. Actually, do you want to give some of the resources and then do the assignment?
Let's see. So is this where you wanted to be, Betsy?
Back one slide. There. See, these are some other sort of deepening resources that we found. Just information about forces in motion, some videos, some games, and an alternative, a tube ramp with a ball and pennies. So other ways you can kind of do similar things. So if you're interested in pursuing this more, those are some resources for you. And then
we put an explanation about what it is. So this is a very similar activity, but it adds metrics. This is sorry, these are reversed, but Bumper Ducks is the video game. The Science Bee is a quick explanation of the basic concepts. So we'll clean that up. And then I wanted to just add one more thing, which is the idea that we want you to try and engage in this series of activities with your students in the next month. And then we're working towards this idea of a multi-step, or what we call a chain reaction. So after the November workshop, to extend the students' learning, we'd like to invite you to think about this idea of a multi-stage reaction, a chain reaction, a Rube Goldberg machine, where this is happening that causes that to happen, that causes the next thing to happen, all to get to some goal, a goal-oriented chain reaction. So that's what a Rube Goldberg is, and we'll come back to that in November. Just think about these activities we did today.
There's a really good example of a Rube Goldberg machine, I guess you would call it. And I don't know if it's still around, but or if you can get it, but it's called Goldie Blocks. And they had done an advertisement in their whole house of how they did a whole setup, the domino effect, right? And the whole thing was a chain reaction, and it was pretty awesome. But I think they had to take it down because they used the wrong music or something.
If you all have stuff to share at the next round, would love to get that link or a connection to that. That sounds wonderful.
There's a lot of really good ones. Okay, last slide.
All right. Oops. Maybe that was the last slide.
It's not the last slide.
Is there a last slide, Betsy? That might be it.
No, you have more, or maybe it's the other way.
Sorry, I lost it.
Where's the slideshow?
And is this slideshow available to us? Did you say?
We're going to make this available to you. Yeah.
Okay, thank you.
Well,
it'll come back in a second. Sometimes it takes a second for it to reload.
What we want you to do between now and the next meeting is I'm trying to find it here.
This one, Betsy? I think I got it.
Got it?